The distribution of different grain sizes affects the engineering properties of soil. Grain size analysis provides the grain size distribution and classifies the type of the soil. The grain size characteristics of soils that are predominantly fine grain are evaluated by a hydrometer analysis. A hydrometer is an instrument used to measure the specific gravity of liquids. That is the ratio of the density of the liquid to the density of water. A hydrometer is usually made of glass and consists of a cylindrical stem and a bulb weighed with mercury or lead shot to make it float upright. The liquid to be tested is poured into a tall container, often a graduated cylinder, and the hydrometer is gently lowered into the liquid until it floats freely. The point at which the surface of the liquid touches the stem of the hydrometer is noted. Hydrometers usually contain a scale inside the stem, so that the specific gravity can be read directly. A variety of scales exists and is used depending on the context. The experiment aims to determine the percentage of different grain sizes contained within a soil. The hydrometer method is used to determine the distribution of the finer particles. Drying oven. A thermostatically controlled oven capable of drying the soil specimen. Sieve number 200. The sieve used to identify the diameters of fine-grained particles of soil. Dispersing agent or sodium hexametaphosphate. The addition of a dispersing agent to the soil suspension results in an increase in density of the liquid and necessitates a correction to be observed in the hydrometer reading. Beaker. A container for the measurement of 125 ml of dispersing agent. 1000 ml graduated cylinder. A container for the mixture of soil, dispersing agent, and distilled water in the experiment. Hydrometer. Hydrometer 152H is an instrument used to measure the relative density of a liquid. Hydrometer is made of glass and primarily consists of two parts: a cylindrical stem with graduation marks and a bulb weighed with mercury or lead to make it float upright. Thermometer. A device used for determining the temperature of the solution. Step 1. Oven dry the soil to be used in the hydrometer analysis experiment for at least 24 hours. Sieve the oven-dried sample passing through sieve number 200. Step 2. Prepare 125 ml of the dispersing agent into a beaker and add 125 ml of the dispersing agent. Take the fine soil, at least 50 grams, cover the beaker with rubber gloves, and let the soil soak for at least 10 minutes. Step 3. Into the control cylinder, fill it with distilled water to the mark. Take the reading at the top of the meniscus formed by the hydrometer stem and the control solution. Step 4. Mix the solution for a period of 2 minutes. Then, add distilled water up to the mark. Step 5. Cover the open end of the cylinder with a stopper and secure it with the palm of your hand. Then, turn the cylinder upside down and back upright for a period of 1 minute. The cylinder should be inverted approximately 30 times during the minute. Step 6. Set the cylinder down and record the time. Remove the stopper from the cylinder. After an elapsed time of 1 minute and 40 seconds, very slowly and carefully insert the hydrometer for the first reading. Step 7. The reading is taken by observing the top of the meniscus, formed by the suspension and the hydrometer stem. For the last step, take hydrometer readings after elapsed time of 1, 2, 4, 8, 16, and 32 minutes to at least 24 hours. A number of errors, both instrumental and human, were encountered during the experiment which may have resulted to the inaccuracy of the data obtained. First error is the possible misreading of the measurements due to the poor eyesight of the exhibitors and the confusion between the upper and lower meniscus formed inside the measuring container. The process of transferring and mixing the liquid may have also added error since they were both done manually and an amount of liquid in the mixture may have spilled out during the process. Lastly is the inconsistency in checking the reading at the desired time, especially between the 1, 2, and 4-minute lapse time since it was difficult to measure with such short time intervals. The sieve analysis test has its own limitation. This limitation covers that it can only measure particle sizes of coarse-grained soil having diameters ranging from 4.75 mm to 0.075 mm. It is not practicable to design a sieve having a screen size smaller than sieve number 200. Therefore, hydrometer analysis is done for fine-grained soils. To be able to achieve more accurate results in this experiment, the hydrometer should be properly calibrated. The meniscus correction must be applied correctly to the actual hydrometer reading. The thermometer should be functioning well as temperature correction plays a role in the computation process. Interpolating and extrapolating can be necessary to acquire K and correction factors. Thus, extra care should be observed in doing so. Most importantly, the exhibitors should obtain the soil specimen that passed through sieve number 200 to be able to achieve the objective of the experiment, which is to determine the distribution of finer particles.